Okay, so transformations of functions. This is something that you have been working on through the last few years of your math career, right? So we're going to do a quick review, and then you'll be expected to kind of go through, and we'll go through more in class and harder examples and kind of work our way through it, okay? These are the main things that we're going to be working on. Is first of all, we have if you add or subtract something to the inside of the function. So here, if I take, so I guess I need a page. If I go from just my regular function and I add an a to the x value. Okay, now think about your axis that you're drawing a graph on, right? This is what's called your x-axis. And this one, I can't write with this at all, sorry. And this one is your y-axis, okay? So this is x, that's supposed to say axis. Axis, I need to like write bigger, axis. Okay, so y-axis is up and down, and the left, this one here is your x-axis, okay? So if you're going along and you're adding just to the x value, then this is what's going to move it along your x-axis, and that's kind of how I remember it. Okay, so this value is going to move it along the x-axis. So an example of this would be f of x equals, maybe I have x plus 2 squared. Well, my parent function of this graph is x squared, but within that, it has this plus 2 inside next to the x. So this is going to shift it. Now here, it's going to move it left if a is positive and right if a is negative, okay? So it's a little bit, so it's going to move it left 2 in this situation because it's positive, okay? All right, so now let's look at the next thing. Okay, so the next thing, one more thing on this. Okay, so normally you would see this plus. To me, I would think of it in a different direction, right? But if it's positive, it's actually going to move it to the left. So it kind of is opposite of what you're intending, right? So if it's positive, it's moving it to the left. If it's negative, you're moving it to the right. And it makes it a little bit trickier just because it is a little counterintuitive to me at least. But hopefully you can kind of get it in your head. Now what you can do is what we've done in previous lessons. If you're not sure which way it shifts it, plug in a test point. Make sure if you're thinking it's going to shift it to the left 2, then you could plug in -2 and make sure that it's at 0 at that point where it's shifting it. Okay, so you can use that idea of plotting points, and that's why we went over that, is to test and make sure that you're doing it correctly. Okay, the next thing that we're going to be dealing with is moving up and down, right? So we take, if we have a function, oh boy, it's going to make me, and we are going to, if we add or subtract something, the positive will move it up and negative will move it down. So this one is more kind of what we think of, like what you actually would anticipate would happen, because positive sounds like up, right? So here, this would be something like, in this case, in the example that I gave you with the x squared plus 2, this is now, instead of adding it just to the x, the plus 2, it actually is x squared and then plus 2. Okay, so your function and then add 2. This was your function within your function you had plus 2, was making it so you had your x plus a. Okay, so this one is on the outside, and that would be the difference between those two. Is this one, as you can see, before you squared it, you added 2, and this one you add 2 after. Okay, so just kind of the difference between the two. Okay, this one moves it up, this one moves it down. Okay, next one, moving on to all of these, we're going to get through them all. This one, if f of x, oh, that was the same thing. Oh, just kidding. I have the exact same thing right there. Okay, next one. Okay, now what about this one? If you have where the x value is negative. Okay, now this is inside. So with the way that this parentheses is, this is where the negative value is inside. Okay, so that example would be f of x equals negative x squared. Okay, you're putting it inside whatever's happening to it. It's inside the parentheses, inside there with it. This reflects it over the y-axis. Okay, now in the case of x squared, it is symmetric around the y-axis, so it actually doesn't do anything to the graph. It looks the same, right? But it is still considered to reflect over that y-axis. Okay, which then gives us what happens if we have a negative here. If you're on a negative on the outside of the function, that reflects it over the x-axis, okay? So now this, if we have f of x equals x squared, and we're going to actually take the negative of this entire thing, then this is going to reflect it over the x-axis. Okay, so let's look at what each of these graphs look like for our examples. And that kind of helps you see how these are moving around the graph as well. We're not going to talk about, well, actually make this. Stretching and shrinking is the numbers out in front. I think I'm going to start with this. I want you to get really comfortable with this and just know that those numbers stretch and shrink, but I'm going to expect you to do a lot with this. I'm very comfortable with how it's moving. To me, stretch and shrink should be found more with plotting points, becomes more accurate, right? And it's just less to try and kind of get confused about if we do the stretch and shrink with plotting points once we know kind of the general shape. Okay, so here, now I'm going to take and get like a little graph of each of these, okay? So this shifted it, remember A was positive, so it shifted it to the left 2. Okay. This one shifted up 2 because I had a positive 2. This one reflected it over the y-axis. Okay, now the y-axis is the center one, so it looks exactly the same. You can't tell that anything's changed because it's symmetric about the y-axis. And this one here reflected it over the x-axis and made everything negative. Okay, okay, so that's kind of the transformations that we're going to focus on. Okay, I'm going to let you come to class and we're going to go through those and have some tricky ones for you to work through.